Hi, this is Kiran. I'm the author and founder of Traffic Squeezer, which is an open source Linux based WAN optimization solution, and author and founder of Aquarium, which is the open source Linux web GUI. And this is a video series about Linux based networking, and in this video I'm just going to explain about the concept called administrative distance. Those who are doing certification courses like CCNA and CCNP, they may come across this term, and it is one of the important exam based questions which is asked. And also who are into generic network administration, and as well as the network administrators who deal with routing policies and stuff like that in their router should know about the administrative distance, because sometimes even though if you set a specific route, it doesn't mean that the network packet processing should happen through that route, or the route which you see in that listing of the routing table list as such. So that's what the administrative distance is. Basically it is a parameter to choose kernel. It's a kind of parameter to choose the router to pick a specific routing entry to process the packets. Say assume you have two entries like A, this is one entry, and B, this is one entry, and just this is one entry, and B, this is one entry. And in this case you have a specific destination network address, say suppose 10.0.0.0/24, and you have another routing table entry which is again pointing to the same destination address like 10.0.0.0/24. In this case you have a case like this where you have two routing entries. So how do the router, suppose you have a router which gets packets in this port, and it has to forward the packets either on these interfaces. Suppose if you consider this as ETH0, ETH1, ETH2, and assume A is pointing, if this is the packet destined to this subnet, then forward it via ETH1, and that is what this rule says. In this case it says forward it to ETH2. And in such a scenario, when you get a packet, so how do the router takes a decision to choose which route among these two? Because if you don't have a kind of metric, the router doesn't have a clue which one to choose. So it is nothing to do with any first come first serve basis or the order of the routing table entries. Instead it carries a weightage, something like administrative distance. Assume this route you got it via the dynamic routing protocol RIP, and it can be any RIP variant, and assume this you have configured a static route, which is a static route, which means you have entered this manually and saying that this particular subnet is supposed to be destined to through via this particular port. So in this case you have two identical routing entries. So automatically what happens is the routers will carry something called as administrative distance. The default administrative distance for all of the RIP variants is 120, and the default administrative distance for a static route is 1. So which is more like ranking. So the router will choose the least most value of administrative distance as its route preference. So in this case what happens is the router will choose this specific routing table entry and forwards the packets accordingly. So in case you have a packet which is entering through this port, which is like 10.0.0.25, which is destined to this this subnet, what happens is due to the administrative distance it chooses a static route instead of a RIP acquired dynamic route, and it forwards through this port. So this way the administrative distance is what controls which route to choose when it is about choosing the forwarding of the packets. So here is the administrative distance table, which is I just wrote for reference. So in this case, as you can see, if it is a static route, these are the administrative distance values, and this is the routing protocol or a specific scenario what happens with respect to that administrative distance. In this case, the most frequently used cases are like this. I mean, static route, you have the administrative distance value is 1, and on the other contrast, if it is a route which is not reachable or a sort of unknown path which is having the administrative distance value of 255. So these are some of the most kind of values which one can remember as such. So even as a exam point of view, you can be asked specific questions on this randomly. You can be asked what is the administrative distance for RIP protocol, and sometimes they give the value of 120, and they may ask what could be the administrative distance corresponding protocol or the routing protocol of the value 120, something like that. So anyway, in some of these cases, some of the most frequently used values should be remembered, or something like this. If it is 1, it's like a static route. So obviously these dynamic routing protocols derive the routing paths, or and populates the routing table dynamically based on the kind of the packet exchanges and the advertisements. It happens as a part of dynamic routing protocols. As you know, the dynamic routing protocols, the main advantage is the administrators don't have to configure the routes. Instead of, it is learnt dynamically during the course, and each router broadcasts that to the subsequent routers, and eventually all the routers will be aware which way to forward the packet. So that's the major advantage of using any kind of dynamic routing protocol. So the administrative distance for all these protocols will have a different weightage rather than using a static route. The static route, obviously the administrator is well aware to choose a specific route in order to avoid congestion, or it can be a decision based on network optimization, something like that, as network route optimization, something like that. So always static routes carry more weightage than any of these dynamically routing protocol acquired routing table entries. So if you have a routing table and you have n number of entries, and some could be RIP, some could be OSPF and stuff like that. So if there is a static route, obviously if there are identical rules as I explained before, obviously the static routes are more carries more weightage in terms of taking packet routing decisions. So if it is a directly connected network, then its administrative distance value is 0. So now in the case of RIP, it is 120, EGP protocol it is 140. So it is kind of increasing numbers, which means least priority, whereas decreasing numbers, which means highest priority. So if you have any identical routing table entries, which is one is acquired via OSPF and one is acquired via RIP, then obviously OSPF will carry the more weightage in terms of taking the packet routing decisions. So this is what the value administrative is all meant for. So any kind of Linux based administrator, and even the students who are kind of doing Cisco networking courses and stuff like that, they should be well aware of what is the overall context of administrative distance, and in terms of their examination point of view, sometimes they need to remember these values so that they can answer those specific queries in the exams as such. So thank you for watching this video, and please subscribe to this channel so that more and more, if you get if I publish more new videos, you can get direct updates from Google YouTube channel. So thank you for watching this video.